Okay, guys, welcome to another lab day. We're doing density again. This time what we've given you is 4 objects that are all the same size, but they're made of different materials, and we want to see how the densities compare between the different materials. So what you have are cylinders. First thing you're going to need to do is get the data table into your ISN, or you can pull this sheet. I'll have it in there for you. And you can see that Ms. Garcia has put down the color of each cylinder, since this particular set has 4 different colors, and that makes it easy to tell them apart. So we're going to do the same thing we did in yesterday's lab. We're going to take the mass, and then we're going to need the length, and I'm going to explain about the volume calculation in a minute. So let's start. Let me get my triple beam balance back to 0. We're going to start with this one. 100 is too much. 10, 20. Okay, 30 is too much. Back to 20. Slider in the front. Oh, not too much. Wow. I think it is. There we go. So it's 20.4 grams. Now, for a cylinder, to calculate the volume, you have to do the area of the base, which is this circle, times the length. And it's hard to measure these, find the exact diameter so you can get the radius, because remember, a circle is pi r squared. So I kind of already did that for you. And so you'll see that the area of a 1 centimeter circle is 0.785 centimeters squared. And so I have that number already in the data chart and in the instructions. And so I've already done that part for you. So all you really have to do to calculate volume is find the length of your cylinder and write that down. And then you're going to multiply that length times 0.785, and that's going to give you your volume. Okay, so this one is 5.8. Now they should all be 5.8. I'll double check them. But they're supposed to all be the same size. So, yeah, that one is. And the black one is. That one's a little bit slanty on one end, which it shouldn't be. Yeah, this one. So they are all 5.8. So you can fill that in for the whole thing. So all we really need to do now is collect the mass of each one of them, and then you'll be able to calculate your volumes and then your densities. So this white one, yeah, back to 10. It doesn't weigh much more than that. It's almost at the middle right now. Just a smidge more. There we go. So it is 20.8. Oh, I'm sorry, 10.8. Thank you, Ms. Garcia. This is why it helps when you're in school to work with partners. They help keep you from making mistakes on stuff like that. And what's next? The black one? Okay. 10, 20. Oh, 20's back to 10. Let's see what we got here. A bit more. Okay, it looks like we are at 11.7 grams. And then what's left? The gold one? Whoa, that one went clunk. I can tell that some of them are heavier just by how they.
One maybe.
Oh, maybe, because that's pretty heavy. No, too much. You're right. I always should start with 100, though. That was my being not a good science person. It happens. Everybody has days like that.
It's probably going to be on 9.
Yes, it's going. Nope, it's cranked at 70. So 60 something. Let's get this other slider going. Oh, that was too far. A smidge less. Okay, I'm pretty happy with that. That is 63.2 grams for that one. So, just like yesterday, you've got to do the calculations now. Remember, you're doing your length times 0.785 centimeters squared, and that's going to give you your volume. and that's going to be in centimeters cubed. And remember also that 1 centimeter cubed is equal to 1 milliliter, so those are interchangeable. So that's how that'll work. And then their density is going to be your mass divided by your volume, just like it always is. And I've put the formula there for you as well. Again, you have questions to answer. They will be on that quiz platform that is the next assignment, but you're also going to do a bar graph for this one. So students in school will see this. You can print this if you have a printer. If not, you can just draw it on a piece of paper, or again, you can go to one of those online websites. Remember, you're doing 1 bar for each cylinder. You're going to have to put on your scales, your titles, all those things that make it a good graph. But the graph is going to be 20 points, and the questions are going to be the other 80 points. So make sure you take the quiz for your 80, which is going to be your lab grade, and then the 20 points for the graph, and we'll add them together.